The figure shown above shows a sketch of the curve y equals f of x. The curve passes through the point 0, 3, 4, 0 and touches the x-axis at the point 1, 0. On separate diagrams, sketch the curve with the equation y equals f of x plus 1. That plus 1 is on the inside of the function, so it affects the x coordinates only, and I do the opposite. So I'm going to subtract 1 from all of the x coordinates. So that's going to shift the graph 1 square in the negative direction. So the coordinate that was 0, 3 is now going to shift 1 square and be at minus 1, 3. The coordinate that was at 1, 0 is now going to be at 0, 0. And the coordinate that was at 4, 0 is now going to be at 3, 0. So my curve is going to look like this. It touches at the origin, comes back up, and back down through at 3, 0. So that's my answer for part A. Part B, we're doing y equals 2 f of x. So what that does, the 2 on the outside there affects the y coordinates and the y coordinates only. And we're going to times them all by 2. So the y-intercept that was at 0, 3 is now going to be at 0, 6. Where it touched on the x-axis here, where the y-coordinate was 0, it's still going to be 0. And again, where it passes through here at 4, 0, it's still going to pass through at 4, 0. So my curve is going to look like this. It's just stretched in the y direction, so it's going to go up more in the y direction, like that. And then part C, y equals f of 1/2 x. So the 1/2 on the inside there affects the x coordinates and the x coordinates only. And we're going to do the opposite. So instead of dividing by 2, we're going to times all the x coordinates by 2. The y-intercept is unaffected because 0 times 2 is still 0. The root at 1 is now going to be at 2. And the root at 4 is now going to be at 8. And so my curve will look something like this.